let's little bit talk about the infrastructure or the components, overall components that I use in the production and test environment. There are some quite some changes now. So first of all, I recreated the firmware. It was first called DOL and was an Arduino project. Now it's a platform IO project, and I yeah transformed all the Arduino files into C and H files, header files, and also use FreeRTOS in a much smarter and cleaner way. So completely rewritten the firmware, and so the on the local development environment, I still use Docker Compose and Docker Compose CUDA version, or two YAML files. One is running on the GPUs for text-to-speech, speech-to-text, and the LLM, Olama. And I also use now PG Vector for vector database. Previously, I used ChromaDB, but this didn't work so well with LangChain, so I switched to PG Vector. It's working much better now. Yes, and what's also new is I created a new service. It's called StreamRecorder. It's a Dino application. The reason why I use that is I come back to that later in 1 minute. So on the production side, I also added a couple of more services for Grafana to have a dashboard to view monitoring and logging. I use Loki for logging and Prometheus for metrics. And so I send information about some services and logs to Prometheus or Loki, and then I display that with Grafana. Works quite well. And yeah, that's it. Mosquito is also running on production. And these services, because I don't have a GPU on my production environment, I use external services for text-to-speech. I use 11 Labs for Open AI Whisper. I use Assembly AI, or Grok Whisper is also possible to use. And for the LLM, I use OpenRouter or Grok as well. So these services are external. So the reason why I have now a StreamRecorder. So the production environment should look like similar to this. Here the user has one network. The red box is a network with maybe a computer and a smartphone that runs the React application. And the React application is connecting, is the React app front end is running on a browser, on a MetaMask browser inside MetaMask, or on the desktop computer, it's running on Chrome with the MetaMask extension. And it will have two connections. One is for the API connection to get REST information about all the REST API, or the API with JSON is running on HTTPS, and Mosquito for system events or like push notifications. So when a new message is arrived on the backend and so on, the API will then, or the backend will send a message to MQTT broker. Then this will be pushed to a specific topic which the user has subscribed to, and you can see that I have not all services running on HTTPS, and the reason for that is the MQTT is currently not running on HTTPS. I will try to do that in the future. It was quite complicated to add the credentials and some certificates and so on to the life cycle, and when a new user was added. So I'm still trying to figure out how to make the user authentication, bring the user authentication from the backend to the MQTT server and use HTTPS. But in the meantime, I use HTTP. This is not a problem because the information which is sent through the MQTT server is only the record type, the ID, and what happened to this record. For example, message was created with ID. This information will then be sent to all the clients, and then it will be it will ask for the information through HTTPS. So yes, it's quite public. You can subscribe to it, but you don't know what to do with this information because these are only IDs that were created, and you don't know. All these topics are quite nested with complicated UIDs. You cannot understand what's going on there without asking the API a bit for nested structured JSON information, because you cannot access this without API key and not going through an HTTPS. So I hope I will fix that later in the future to use also HTTPS to have a login mechanism to the MQTT broker. The only thing that will be not be HTTPS in the future is the HTTP post streaming. I tried it in the past to make it HTTPS, so the ESP32 is sending a post stream event to the API, and then it will process the message as normal. But I had quite a lot of problems because the handshake, the HTTP handshake, was quite slow. So when you want to start a conversation, there was always a small delay of one second maybe to start the handshake. So when you start a conversation, you then start speaking, and then I even try to separate the sign in from recording. So I created two separate RTOS buffer tasks. One is for connecting to connect to the backend, and the second one is to start recording to a buffer. And after the connection was established, it starts streaming. But yeah, this didn't work. Then I said, okay, don't make it's not a problem, because the doll will always be running on a local network. You're not going to bring your doll to a public McDonald's Wi-Fi network. Then people can read your communication, your audio communication. So I think this is fine for now, because the connection between your network and the Salvador's network is encrypted when you have an encrypted network Wi-Fi. So this is not a problem if you stay locally in your secure network. So when you start streaming, I didn't say why I moved it to a different service. So in the past, you were creating an HTTP multi-form data event to the API, and then you create a message this way. I didn't want to expose the API to HTTP, and I want to remove the post streaming from the API. So the API is only receiving standard HTTP post requests, not streaming. And this way, the API is working in a standard way. You can still send via the React application. When you start record, you create a record message, click the button, start record, release a button, and it will send an HTTP post, multi-form data post event to the API. But the DOL is not using form data post requests. It uses post stream, and this is different from the standard API endpoint. So what I did is to create a StreamRecorder service in Dino that receives a post stream event, a WAV file, and then it will get the chunks. When you stop recording, you will send a stop event for the recorder. It will then close the file. Then it will transform the file from a WAV to an MP3. And then it will send the file to the API locally. The same way the front end is sending the post request. So it will send after you stop recording, it will then convert the WAV to an MP3, and then it will make a HTTP post multi-form post data event post request to the API, and then the same mechanism as the front end with MQTT again to the DOL and the front end, and so the StreamRecorder is only for receiving an HTTP post stream, and then after the post stream is closed or broken, it will try to close the file and transform it to an MP3, and then if that works, it will post that to the API. This way I can expose a separate service with HTTP. This service is only accessible via HTTP. It's not accessible via HTTPS. The API is only accessible via HTTPS, but you can send data to the API via HTTP through the StreamRecorder. So it will stream to the StreamRecorder, then it will send the post request to the API, and then it will update the record, the message, or will add a message to the chat history.